Hi, in this video we will talk about logic functions. So Boolean functions are defined as an expression. In this case you're seeing a function which is dependent on variable x1 up to variable xn, whose values can be 0 or 1 according to the values, of course, of the input variables. Since there are n variables and each variable has two possible values, we have 2 to the power of n combinations. Even more, the function can take the value of 0 or 1, so there are actually 2 to the power of 2 times n different functions, where n, of course, is the number of variables. So the question is, what are the possible functions if n equals to 1? The answer is 4, because we have 2 to the power of 2 times 1, so it's 2 to the power of 2, which is 4. So what are those 4 possible functions? So in this case, if we have one variable, this variable we will say that is x. So the first possible function would be f1 equals to 0. And you can see that the truth table, if x equal to 0 or 1, the function is always going to be 0. The second function would be function dependent on x is equal to x, which is a buffer. In this case, you can see that the function is actually the same as the input. The third possibility is that the function is equal to the inversion of the variable. And finally, the fourth choice is when we have the function being 1 all the time. You already know what a sum of products is. You already know also what a product of sum is. But now we have canonical forms. And canonical forms are actually also sum of products and also product of sums. The difference is that in the first canonical form, which is called Minterm, in this canonical form, the sum of products is special in a way in that all the variables are included in each AND term. And the other canonical form is the Maxterm, which is a product of sums. In this case, all the variables are included in the OR term. So here we have an example of a sum of products. Now we have a product of sums. However, these are not canonical forms of functions. In the sum of product example, we have 3 variables. So what the canonical form, which again it's called Minterms, the Minterms are supposed to have all the variables included in each AND term. The first AND term is a.b. So the question is, are all the variables, which in this case are a, b, and c, included inside this AND expression? And the answer, of course, is not. We are missing the c variable. So because of that, this expression is not considered a Minterm. This expression is considered a simple sum of products. An example of a Minterm would be something like this. In that case, both AND terms have all the variables included in this expression. However, if I add a third term, by doing this, the whole expression, it's not considered canonical. The same happens with product of sums. In each OR, we have to have all the independent variables. We have to have them inside each OR expression. So that's the difference between a simple sum of products and a canonical sum of products, and the same with a product of sums in the simpler form or in the canonical form. Minterms, as I already explained, it's an AND function with all of the independent variables included in it, so that the function is equal to 1 in just one of all the possible input combinations. This is very important. This is the definition of Minterms. Only in one combination, only in one row of a truth table, for example, only one row of that truth table can be 1. All the rest of the combinations have to be 0. Let's see an example of a Minterm for a 3-variable function. This function, it's a Minterm because we only have one of the 8 possible combinations as a logic one. All the other combinations, the function is equal to 0. This is what's called a Minterm. And the expression, it's what it's showing, that in this particular expression it's going to be 1. And to see that, we can evaluate this function. If you see, we have a dot b inverted dot c inverted. So if we write the values a, b, and c, we know that a is 1. So we're going to write 1 here, dot 0 because b is 0, dot 0 because c is 0. However, since we have the inversions here, that means we're going to invert the zeros. So this is going to give us 1 dot 1 dot 1, which of course is going to be equal to 1. This expression here, it's only going to give us 1 in that particular combination. You can evaluate this function in any other combination. For instance, you can try it with this one. I'm going to do it a little faster. And as you can see, in that combination, the function is going to be 0. Now, another important thing is that this minterm, it's called minterm number 4. Can you guess why? And of course, the answer is pretty simple. The combinations are actually binary numbers. So this is binary number 0. The second row is binary number 1 and 7. And of course, you can see that the function is 1 on the fourth combination. That's why this is called minterm 4. What we saw on the previous slide was just one minterm. Now let's see all the possible minterms for a 3-variable function. In this case, we're showing 8 different functions. We're showing minterm 0 to minterm 7. And as you can see, minterm 0, only on the combination 0, the function is 1. Minterm 1, only in combination number 1, the function is 1. And so on. Now, what about maxterms? Well, maxterms are the opposite. Maxterm is an OR function with all the independent variables included in it. So that the function, now here, take a close look, that the function is equal to a logic 0 in just one of all the possible input combinations. Now let's see an example of a maxterm for a 3-variable function. Here we have only that in the first row, the function is 0. And the expression that helps us in a way that only in this particular combination the function is 0, it's this one here. See that the function now it's ORs, they are not ANDs. Now, here the function is 0 because if you take these combinations, then we're going to have 0 or 0 or 0. And of course, this function is going to give us 0. Now, the interesting part here is that in any other combination, this function is going to give us 1. You can try that on your own. Now let's see all the possible maxterms for a 3-variable function. Now see the difference is that now maxterms almost all the time have 1s, but they have 0s in specific rows. Now let's see a list of all the possible minterms and maxterm expressions for a 3-variable function. And this is just for you to see some relationships. Now take any expression. For instance, take this expression over here, minterm 3. Now minterm 3, it's actually very easy to get because minterm 3, it's actually the number 3 in binary. So for instance, if I tell you, and this is going to be like a hard, let's say, question. If I tell you that we have a function and I want this function to be minterm 12, and I ask you, which is the expression of minterm 12? Now, you may think that you have to build all the truth table to get this function. And actually, you don't have to, because you can see some relationship here. Let's try to get number 12 in binary. So in binary, we have spaces, and each space is worth something. In this particular case in binary, the first digit is worth 1, the second digit is worth 2, the third digit is worth 4, and the final digit is worth 8. So now to get number 12, we actually need to sum 8 plus 4. So that means that I have to have a 1 here, a 1 here, and zeros here. That way I'm summing 8 plus 4 plus nothing. So that means that number 12 in decimal is equal to number 1, 1, 0, 0 in binary. What that tells me is that this is the combination in the truth table in which this function is going to be 1. So all I have to do is use this information and say, okay, since the first variable, this is the first variable, in this case the first variable, it's x, as you can see here. So the first variable, it's 1. So since it is 1, I don't have to invert it. So I just write x. Now, this is a sum of products. This is a minterm, so I have to AND it with the second variable. The second variable would be y. The third variable would be w. However, the w, since the w is 0, we would have to invert it. And the zeta is also 0, and we would have to invert it. So that's the easy way to get minterms without building the truth table. You can see the number of minterms, and then you get the expression. Now, here's an important notice. Minterms are actually the opposite of maxterms, and vice versa. Maxterms are the opposite of minterms. With this, I can tell you that if I take this row here, that means that the utility of this is that we can build any function if we use minterms or maxterm. With minterms, we simply take the ones of the function and convert those ones into minterms expressions and then put them together through the OR operation. With maxterms, of course, is the opposite. We take the zeros of a function, convert them to maxterm expressions, and then put them together through an AND operator. Let's see an example, and let's see this with a truth table so that it may be easier for you to understand. So here we have a function, and in this function we have 3 ones. Now, those 3 ones are actually related to those 3 minterms, and you can see why. Minterm 2 because this is row number 2, minterm 4 because this is row number 4, and minterm 7 because this is row number 7. Now the question is, how can we combine all those 3 columns into just one function? And the answer is simple. We have these 3 columns, which are the minterms, and the way to make this, we simply OR them, because remember the OR, which means that only one has to be present, and if one is present, the function is going to be 1. So in this way, we have a 1 here, which is going to go to the function, okay, and that's because we're putting ORs. Now, that means that this function, it's actually this. The function, it's actually minterm 2 plus minterm 4 plus minterm 7. And here we have a compact way of expressing functions. And that's doing the sum of minterms 2, 4, 7. And of course we have the long expression, which is all variables in the function. Now let's see a Maxterm example. It's the same, but working with zeros. And here I already have the function, but again, we take a close look at the zeros. We have a 0 here, we have a 0 here. We take those zeros and put them into Maxterms. Then the only way to combine those 2 zeros and get them into one function is through the AND operation. That way, if we have only 1 0, then the 0 is going to go to the function. And the compact way to express this is either by putting maxterm 0 dot maxterm form, or in this case, this is not the sum, this is not the symbol, we use this symbol, which is the multiplication symbol. So we use the multiplication symbol of maxterm 0 and 4. And of course, we have the long expression. Thank you very much for watching. See you on the next video.